Hi, welcome to my ArcGIS tutorial on geoprocessing tools. I hope this tutorial will be useful for people who are new to geoprocessing tools and want to know what they are, how to find, use, and how to troubleshoot them. Let's see what we will cover in this tutorial. First of all, we will know about what geoprocessing is. What are the common geoprocessing tools? Then we will see some practical application of them. Then we will learn how to get documentation, how to find tools, and how to use the results window. A tool is any instrument or simple piece of equipment that we use to do a particular kind of work. Mainly inside the computer world, a tool is used to do some kind of manipulation or work. Geoprocessing is a geographic information system, a term used to describe any of the various processes in which specialized software tools are used to compare, analyze, or manipulate map layers and their underlying geographic data to create new sets of data. Geoprocessing yields relationships about geographic information that would otherwise be difficult to visualize, interpret in a geographic context. You can think of geoprocessing as a language where nouns are geographic data such as features and tables and rasters, and tools are verbs such as copy, clip, and join. Like any language, there are a handful of nouns and verbs that we need to know to communicate, and this section and the other sections that will follow introduce you to these common geoprocessing verbs or tools. To summarize, geoprocessing tools are used to do something with the geographic data. Each individual tools can do individual tasks. A tool alone may not be much helpful, but when combined, they can solve complicated problems. Common GIS analysis tools are buffer, clip, dissolve, intersect, merge, union, etc. Let's start with the clip tool. It can be found from geoprocessing option in menu bar. So let's try it. Let's consider the situation like this. We have a large data set, but our study area is small. We have the large data set and the boundary for our study area. If we keep working on the whole data set, then data analysis, previewing, and overall ArcMap experience will be slow because every time ArcMap have to handle huge amount of data, although we are not interested about all of them. So we use clip tool to clip out only the feature classes we are interested about. Let's open the clip tool from geoprocessing option. We can see that when we hover over a tool tip appears which shows what the tool does. That's very helpful. Anyway, let's open the tool. We can see that at the left side main window area where we specify input, output and various parameters. On the right side there is help section. If we cannot see it, click the show help button to open the help section. Now we can use drop down or just drag and drop the layers into the input features option and clip features section. It is always good to set the output in such a way that we can remember and understand easily for later purpose. We can also see an optional parameter which we don't bother about now. Let's click OK to run the tool with specified parameters. We can see that the small notification shows at the bottom that the tool is running in the background. It will automatically load the output layer into our current data frame when the tool is done working. Now we can see that we got a new layer named clipped and its shape is equal to our study area. It will contain the data from the whole area. So it will be faster to use the clipped feature class to work. Now, before going to the other tools, I want to show you how to find help if you are stuck. Let's open the clip tool again and suppose we don't know what the parameters do. We can see that the help section is dynamic. That means it will show the help related to the parameters that we are working with now. Also, we can click on the tool help to get more detailed instructions. Now, let's get back to exploring other tools. Considering the same situation as before, let's open buffer tool which creates a constant buffer from feature class with the constant distance from our specified feature class. Let's say our input feature will be study area and we want 250-meter buffer of the feature. Let's specify the output as we like and set the buffer distance. We can also choose the unit if we please. Now, if we run it, we can see our buffer created. I am reordering the layers to make the original layer visible. To make it interesting, let's use the new layer we got from the buffer tool and see which area is intersecting with the quad boundary layer. To make it clear, let's decrease the transparency of the top layer. Now we can see the boundaries of both. We want the intersecting part which is in the middle. Let's open the intersect tool. We can see that we can input multiple layers in this parameter. I am inputting the layers by dragging them into here. Then I am specifying the output location. There are other parameters if we want to change them. We are just testing the tool, so let's go with the default settings and click OK to run the tool. Now we got a new layer. Let's change its color to make it more visible. So we can see that only the intersecting part is included in this layer. We can see it clearly by toggling the visibility of other layers. Now let's use the same layers and use union tool. The process is same, so I don't want to bore you by telling the same things again and again. We input the feature classes, specify the output location, specify the parameters and click learn and click run. Now after running, we can see that we got the geometric union of the areas. We can clearly see that by using the identify tool. Here, area of both layer is kept and the polygons are separated by all the boundaries. Similarly, let's use the merge tool. It can be quite confusing to differentiate the union tool and merge tool if we don't keep a good eye on the results. We can see that the both polygons are kept in the output. Here polygons are kept as it is. They are not separated by the boundaries. All the data is kept untouched, just merged into one layer. But in union they are geometrically modified. Pretty interesting, right? Let's learn some other common tools, but this time we will not use the tools. There are a lot of tools in ArcMap. The way of using the tools is basically same. Set input features, set output features location and some parameters. So showing them all one by one is not practical. Instead, we will now learn what we will accomplish with the tool. Select tool is used to extract features from an input feature class or layer, typically using select or structure query language expression, and outputs them into output feature class. Split tool splits an input with overlaying features to create a subset of output feature classes. Erase tool is interesting. It is practically opposite of clip tool. Clip tool only keeps the intersecting area, but erase tool actually removes the intersecting area. It keeps not intersecting area. Now let's talk about identity tool. It is a tool created for convenience. While we need to intersect an area and then union it with the original layer, we use the identity tool. It does the same thing but in one tool. There are more than 20 toolboxes in ArcMap for different types of manipulation. Each toolbox can contain tool sets that includes the individual tools. It can be quite hard to remember all of them. So, to find the location of tool, we can use the search feature in ArcMap. Suppose we want to use the clip tool but don't currently remember its location. Then we can search for it in search tool. We can open search window from geoprocessing option. Then we can search for tools. Let's say we don't know where intersection tool is. We can search for it here. The results section is multifunctional. We can click on the first link to open the tool directly, second link to find help on the tool, hover on third link to see where the tool is located. We can find an open results window from geoprocessing option. When we run a tool, we can see the small notification panel. It shows whether the tool operation completed successfully or not. We can click on it to get results window too. Let's open the results window. We can see all the tools we used in the session are listed here. We can expand any result and inspect further. We can see the output feature class, its location, we can see the values of different parameters and messages. Also, if we double click on the result, the tool opens with the exact values we used just before we clicked OK. We can see there is an error now because the file name with exactly same name already exists. So we learned many tools today. Let's try to solve a real life situation with the tools we have learned. Here we can see we have 5 layers, each having different elements. Bottom layer is our study area. The remaining ones are different structures or elements. Our task is to calculate area based on the use of land. In short, we want to calculate land use percentages in the area. There are some issues we must think about just before starting. We can see some of the elements are outside of our study area. Also, in the road layer, there are multiple overlapping polygons. This can make our task difficult later. So, let's use the dissolve tool to merge them into one polygon. I am setting the necessary parameters and running the tool. Now we got a road layer with only one polygon, which is enough for our task and make the work easy. Now we must get all the info in one layer with the type of category in each polygon. So let's use the identity tool, which intersects and overlays features on the input feature. In identity tool, I am setting the input feature as the proposed extended area and identity feature as the building proposed layer. After running, we got a new layer with the attributes inherited from their original layer. Let's categorize the polygons before moving further. We can see there are two polygons with no category data. Let's turn on editing and edit them. It will simplify our work later. Let's use the identity tool with this new layer and road layer. We got a new layer with some missing category. Let's fix that again. As you can see, we are cumulatively bringing data of 5 layers into one layer. Let's use identity again with lake and play field and repeat the same process. Let's use the identity tool again with lake and play field and repeat the same process. Now, after filling up the gaps, we have everything in one layer with the category data. Now, we will use the dissolve tool to aggregate the polygons by their category. That means we will get one row per category. Let's recall that our goal was to get percentage of land use. So, we want the percentage of area. We don't have the area field, so let's add it. Then we use the calculate geometry option to get the area for the categories. Also, let's add a percentage field with float as its type. We know that any percentage is any row divided by total multiplied with 100. We can get the total area from column statistics. Let's copy the number. Then using field calculator, we can calculate the percentage. We bring data of area divided by total area we copied, then multiply it with 100. Now we got the percentage we wanted. So we can see that although any tool is individually not much powerful, together these can be used to solve complicated problems. I hope you enjoyed my tutorial. See you next time.